All right, just to kind of recap, we kind of ended on the translation of an activity, but we still want to answer some questions. And we kind of rushed through it because we were running out of time in class. So I want to go over this again. Essentially, what we did is we translated. Now, translation is a fancy math word that we use that means that we moved an object in the two-dimensional plane. So over here we have this blue trapezoid, and then by moving 5 units to the left and 3 units up for each point, in other words, to get from A to A prime, I move 5 units to the left and 3 points up. To get P to P prime, 5 units to the left, 3 up. T, 5 units to the left, 3 up. R to R prime, 5, 3. Okay. Then when we connected the vertices, vertices is a fancy word for corner, right? So each one of these letters represents a vertice. It's a point, but it's also a corner of this object. And corner doesn't necessarily mean 90 degrees. Well, it does, but I'm not using it in that context. And so what we did is with our little protractor / rulers, we measured it, and what we found was is that TR is 1.3 centimeters. T prime R prime is also 1.3 centimeters. And that RA was 1.7 and R prime A prime was 1.7. So when I say TR, I mean the length from here to here and the length from here to here. Those were actually both 1.3. And then this was 1.7, and guess what? This was 1.7. That's from R prime to A prime, and then from R to A is 1.7. Then we found out that this was also 1.7. A to P, A prime to P prime, we measured that 1.7 centimeters. And then this longer line was 1.75, as was this line here. They were both 1.75. So basically what we have is the same shape that we had before. We just moved it to a different location. How did we do that? We moved every corner or vertex or vertices over 5 units to the left and 3 units up. And so that's what we call translation. And then we measured the angles just to check to see if the angles were correct, and the angles were right too. All the angles matched up. And then we talked about it and it says, what did you notice about the corresponding angles? They're the same, or congruent is a fancy math word that Mr. Adams will use. And then it says, which sides of the trapezoids are parallel? Well, that would be TR and PR. And what about the image of the trapezoid T prime, R prime, A prime, P prime? That's the translated image. Well, guess what? It's T prime, R prime. In other words, we have TR and AP are parallel. Well, guess what? T prime, R prime, and AP, A prime, P prime are also parallel. And then, so what did you notice? They're the same image. We just moved it, right? So when you look at this, this is literally the same. Now, what they wanted us to do is take some tracing paper and trace this out, and then we would slide it over to see that it's the same. But I didn't have any tracing paper at the time we did this. So it's okay. You could see that it's the same. So let's do the next thing. It says reflect. Make a conjecture. Use the results on E, H, and I to make a conjecture about the translations. So what do they mean by that? Well, what you could say is that the size and shape are the same. Size and shape are the same. That's one way to put it. And then another thing, and I don't want to gloss over this, make this a comma, as well as the orientation. So it didn't rotate either. That's a different transformation that I'll teach you later on. Sometimes we could rotate the image, and that changes the orientation. We didn't rotate it. We just took it from one spot, slid it over, and slid it up. That's all we did. Took it from one spot, slid it over, slid it up. Ow. Hit my desk. And so that's the same. And the fancy word for same angles, same length, that's going to be congruent. So those are two congruent images. You'll spend at least a month and a half, 2 months on congruent images. I think I misspelled congruent. That's the weird thing. Like now with yeah, I'm ever since the infinitely many disaster. Now I check my spelling. What's funny is I said to my other class, I was thinking of the word definitely, and for some reason I was spelling it that way, but guess what? It's spelled the same, so I was misspelling definitely too. Anyway, I'm a math teacher. I'm doing the best I can. So it says, number 3, it says 2 figures that have the same size and shape are called congruent. Oh, hey, look, I did spell it right. Yay. What can you say about translations and congruent? Translations produce congruent figures. So if you're doing the PSAT and they say, tell us what transformation you see, and you have an image over here and then another image over here, but they're the exact same size, same orientation, same shape, same angles, and you go, oh, they are the same. That would be a translation because they go from one image over to the other image. That makes sense? All right. I'm going to stop there, give you a chance to write